Hello everyone and welcome to the public space. Today we will be having a discussion with our friend Bill Gaede about black holes in general, but in particular this new picture of a black hole, which is such an amazing picture and it brings such data from outer worlds. I hope you saw the light, Bill. Are you here tonight to tell us that you deny the theory of ropes and that you've been convinced of gravity by seeing this wonderful donut in the sky?
Hi JFG, how you doing? Yeah, I guess we all have to celebrate. Let's pull out the champagne bottles and celebrate, right?
Given the blurriness of the picture, I have to say, I can't imagine, I can't do anything else but laugh at the idea that some people did pull the champagne on this picture. This picture of a donut, of an irregular, asymmetric donut.
Well, you have to keep in mind that 2 years ago they got a Nobel Prize for doing gravity waves to black holes.
Absolutely. And have you been hearing from the LIGO? There are constant developments. They always have signals that they seem to interpret as gravity waves. What's your take on these LIGO results?
Well, not to throw authority on the subject, but Einstein did believe in gravity waves. He wrote a paper against it. Nathan Rosen, his buddy, insisted till the end of his life after Einstein died that there were no such things as gravity waves. How these people infer that two black holes collided billions of years ago and suddenly, we received the gravity waves here, they could be talking about angels for all we care.
Well, but from the moment you can have higher gravity and lower gravity, and I hope you would agree with me on this, you can have waves. I mean, you could have someone playing with the gravitational force such that it's higher sometime, lower sometime, higher sometime, lower sometimes.
Gravity can be stronger and can be weaker. That doesn't mean that it's mediated by transverse waves or longitudinal waves.
That is true. That is true. There must be some sort of a rope or a system of waves that could carry these in the form of waves. I don't even know what's carrying gravitational waves in their theory.
They don't have in fact, that's how I wanted to start the discussion. They don't have explanations. That's the problem with mathematical physics. For the last 400 years, there are no explanations. There are no mechanisms. What they have is mass. They talk about concepts such as field and energy, but they don't have a mechanism. They can't tell you a physical mechanism. If you look at that first picture that I sent you, number one, I think that pretty much tells you the difference between mathematics, what I call mathematics, and real physics. And the difference is that, mathematician, as I call him, he can go in there and tell you what A plus B is. He can tell you that the magician on stage who was cutting the lady in half, used 20 strokes of the saw. He did it in 10 seconds, cut her into two pieces. He can go into the numbers. That's not an explanation. That's not a mechanism. And that's where mathematical physics fails. Physics is what you see on the right-hand side in red. And that's, the guy explaining to you a mechanism. Here you have three different mechanisms of how he could have cut her in half. One, the lady's underneath, has her lower half of her body underneath the stage. And another one, there's two ladies, etc. Okay, so the point is that these are mechanisms. These are how they trick you. This is how the magician fooled you. The other one is just a description, and mathematics can only do what's on the left, and that's what they've done. When these people say that LIGO detected gravity waves or that they took a picture of a black hole, all they're doing is selling you propaganda. They're not explaining anything. All they're doing is saying, look, we took a picture. That proves our theory. What theory? I need a theory of how gravity works, and that's what we don't have. And I mean by gravity works, I mean mechanisms. And this is the problem.
On that, I agree with you. There are two levels of explanation. One is a descriptive one, simply state what happened or what will happen, and the other is a mechanistic one that seeks to find what underlies what we don't see in the mechanism that we observe.
And I'm saying I go deeper than that, a little deeper than that. I'm saying you just used the word description. I'm saying description has nothing to do with explanation. Explanation has nothing to do with description. I describe a chair. It's brown. It's got 4 legs, a seat, a backrest. That's a description. An explanation is, when you explain a mechanism. In other words, you tell the person how something was done. You want to explain how a car works. You make pictures. You make a movie of your mechanism, and the guy watches the movie and he can understand how a car runs just by watching the movie. And you won't find that in all of mathematical physics. There is not a single explanation, and I'll tell you why. The reason is they insist on the particle hypothesis. That's the reason why. They can't explain anything with a particle or with waves, and that's why we're stuck with descriptions.
So I'd like to dig a little more on this so I can understand, because I've been shaking my own beliefs in particles recently. I've been discussing with our friend quantum physicist Peter, and at this point I'm not even sure if I believe that there are particles. I believe only in wave, Bill.
Well, here's a wave, okay? You see the wave?
No, but seriously, you're saying they are insisting on a particle model. Who's insisting? The quantum physicist?
Yeah, specifically. But remember, even general relativity is a particle theory, because general relativity, as well as special relativity, focuses on the photon. And the photon is treated as a particle, as a discrete particle. Okay, so if you ask a relativist, right, and say, well, what is light? He'll say it's a flow of bullets. It's a flow of particles. And are those classical corpuscles? Oh, no. And that's when they start with a hocus pocus. They say, well, it's 0 dimensional. It's got no mass. They go into numbers, and you never see a picture. Whatever picture you put is wrong.
All right. Now, is there such a thing as, people are asking on the regular chat, before we jump into the subject of black holes, about the rope theory, is there such a thing as cutting a rope? Can you break one of your ropes?
Let me tell you, if you look throughout the internet, you won't find my answer to that question. And there's a purpose for that.
So we have an exclusive subject tonight on the public space.
You won't find it on the internet because I don't want it on the internet. And there are reasons for that. The reason is that I discuss those issues with people who are familiar with the scientific method. 99.99% of the people out there are not familiar with the scientific method. They don't know what the word object means. They don't know what an object is, and you can't do physics without an object. They're not familiar with the foundations of physics. They don't know what the word exist means. They don't know what touch means, which you would need to explain that. So they would not be able to understand my answer unless they go through the difficult process of understanding the foundations of physics. And most people are not familiar with them. So people won't, we're wasting our time if I explain the guy didn't understand, because he's trying to visualize this maybe in terms of mathematics, energy, mass, fields, and I'm going to explain with objects. I'm going to say, look, this is a rock, this is a tree, this is a dog, and they're not familiar with that. They say, well, I want you to talk to me in terms that I understand. That's not the way it works. They're going to have to learn it the way I understand it, and that's with objects.
All right, so take us through the black hole thing, what you believe on it, because I don't think that you deny the phenomena that are described as gravity and mass, but you tend to have a different interpretation. So take us through whatever it is that you've prepared for tonight.
Okay, well, the first thing is that, again, I'm saying that mathematics, and this offends a lot of people, mathematics has absolutely nothing to do with physics. And people immediately, they want to hang me for that, for saying this. But there's a reason for me saying that. And this is the reason. I say science is about explanations. Mathematics can only describe, therefore, mathematics has nothing to do with science or with physics. Okay, that's the rationale. That's why I keep saying math has nothing to do with science or with physics. And so when people ask questions relating to energy, mass, what is the distance, we don't care. We don't care because that doesn't explain anything. I don't explain anything by using the word time. I don't explain anything by using the word energy, especially if the word energy has never been defined. I cannot explain what we have, the subject of today, anything using the word mass because the word mass has never been defined. And here I'll just give you a quick quote, if I may, that'll put it in the right perspective. This is from Edwin Taylor and John Wheeler. Some people haven't heard of these guys, but they were physicists. I think Edwin Taylor might still be alive, but John Wheeler died a couple years ago, I think. They say the following in Space-Time Physics, their book. Listen to this. It says, nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term, even if we could count number of atoms or by any other counting method, try to evaluate amount of matter, that number would not equal mass. There is no definition of the word mass today. The Wikipedia has 7 different definitions, and they say, choose the one you want. Whatever mass means to you, that use it. So we don't have a definition of mass. We don't have a definition of energy. We don't know what time is, but people want answers in those terms. And there's no way.
So on that, I agree. I'm personally being red-pilled on the subject of mass recently because I've been watching lots of YouTube videos. Essentially, any definition of mass you use, it appears the mass of a given object that you don't touch will change according to where it is, according to its level of energy, its heat, its movement. If it moves, it stops having the same mass. So we have to abandon the concept of mass as a measure of the universe.
Yeah, you have inertial mass, you have gravitational mass, you have relativistic mass. They created all these masses because they use them ad hoc. They use whatever mass they need for whatever purpose they need. And this is a serious problem. You have the extremes. You have a photon, which is a zero-dimensional non-entity that has no mass, and you have a black hole, which is a zero-dimensional non-entity, which has, I don't know, infinite mass, I guess, because if it's got zero volume, I guess, mass should be infinite. But they
very high mass.
So yeah, very high or close to infinitesimal in the other direction. So this is all math, but I still don't understand the mechanism because I don't have a mechanism from mathematical physics of how mass affects a star far away. I need to know how mass, a concept, kilograms, right? How that bends space-time, another concept which doesn't exist. It's just four number lines, which they call dimensions. They're not dimensions. They're not coordinates. They're known as number lines. They take 4 number lines, they turn them into 4-dimensional object, which you're not supposed to see as an object because it's just an analogy, And so you're not supposed to visualize this. You're just supposed to say, look, you can only understand it through math. But there's no understanding because there's no explanation. All you have is a description. And what is the description? The description is that you have mass, runaway mass, bending space-time, and somehow that affects a star far away. Well, out of the 3 objects that we just talked about, the only real object is a star far away. There is no such thing as mass, and there is no such thing as space-time. And I've got a little GIF there that I sent you. It's number, let's see. Look at number 19.
All right.
You put number 19, 20, and 21, one after another. Here's number 19, right? We have an elephant in a ditch, in a depression. And we have a little turtle that's going around it, because supposedly this is what a black hole is: a big mass in the center weighing down space-time. In this case, made a depression in the ground, and you have the turtle going around. Now we replace the elephant with the word mass. In other words, we get rid of the structure, we get rid of the elephant. We only have his kilograms, his 6 tons. So we have 6 tons weighing down a depression, and the turtle's going around the 6 tons. Okay, no longer around an elephant. Now, why don't you put number 20, the next one? Okay, now we replaced the ground with space-time. We got rid of the ground, which was real. Now we have space-time, which is another concept. We have mass, a concept weighing down. We got rid of that ground. No more ground. Now we have space-time, okay? In a second here. Blip. There it goes. So now we have a concept weighing down another concept, and the turtle going around who knows what, around mass. And if you take the next one, number 21, we got rid of mass, we get rid of the space-time net, the fish net. And what do we have? We have a turtle going around nothing, essentially. That's mathematics there. That's what you're going to learn if you go to college. They're going to say, oh, we don't know the mechanism. We're still investigating. We only have a turtle going around nothing. Around 2 concepts.
Well, nothing, not nothing. A black hole is something.
Well, is it something? That's the other question we have. If you look at which one is it? Look at the first picture first, number 10. Look at number 10. That's the picture that they published, right? So what are we staring at here? We look at that dark smudge in the center of that orange halo, and they say, well, that's an event horizon. What you have is matter, gases falling into the event horizon, right? That's what they say we have. Okay, now here's the $1 million question for any mathematician who is willing to answer it, because I'm sure none of them will. And that's go with the next one, number 11.
All right.
So what are we staring at? Are we staring at a hole, a 2-dimensional rabbit hole that takes you to another universe? Or are we looking at a ball that stands in the middle of the cosmic ocean? See, in the case of the hole, the only way you can see that hole is if you're God and you're outside of space-time or outside of space, and you're looking at the surface of space. Only then can you see the hole. On the other hand, if you're looking at the ball, yeah, you can look at it inside the center of a cosmic ocean, like you see a fish inside the water. But we have a difference between these 2 notions here. The first one is gravity taking you to another universe, right? And the second one, the ball, it's gravity takes you to the center of the ball, to that singularity. So which is it? Is gravity flowing through a hole that takes you through a wormhole, or is gravity something that takes you to the center of the ball? Which of these 2 notions is a black hole?
I will speak for classical physics here, and I will say that the general view is that it's a 3D bowling ball, a black hole, from the outside. Now, from the inside, you can imagine anything you want. You can imagine that it leads to such a peak in the space-time that it brings you somewhere else, or even creates another universe at the end. But as far as our interaction with it, we can rotate around it in a 3D space around a ball.
Well, I would say that you watch too many Hollywood movies. That's what I would say. This is so realistic. There's no way you can reconcile a singularity at the center of a ball, right? Which is what a star collapsed to. It collapsed to a small ball. In fact, you have the definitions there. If you look at number, which one is it? Oh, look at number 13. Yeah, that's the one I wanted. No, that one, the one you just had. That's the right
All
one.
right.
Look at the definition that NASA gives you, and look at the one that on the right, which is given by the Max Planck Institute. One treats it as a physical object, as a ball. The other one treats it as a concept. They say it's a region of something else. Region can only be of something else. A ball is a standalone object. So a region is not a ball, and a ball is not a region. So they have to decide which is it. Are we going to talk about a ball or are we going to talk about a hole? What is a
Well,
black hole?
I will deny this. A region can be a ball, and in fact, any object can be defined as a region in space.
Region is a concept. Look it up. Region is a concept. A region is not a ball.
Well,
Region, like
to the moment you admit that there is such a thing as the surface of an object, then the object can be confined to a region of any universe.
Region is a concept. You can't replace the word ball with the word region. No way. No way. Region is not a standalone object. I cannot bring to you a region and say, this is a region, folks. I cannot point to a region. Region is of something else. I can point to space-time and say, this is a region of space-time. I cannot say, look, I'm getting rid of space-time. I'm going to show you just a region. No way. No way. That's irrationality.
I will disagree on this, but let's keep moving.
Okay. Anyways, if we have a region, I'm saying that we have a difference between the ball and the region. But I want you to look at number 13, NASA. What they illustrate in their website, number 13, NASA.
There we go.
No, it's the other 13. That's yours. I got two 13. One. Yeah, that one. You can see that this region, so-called, it's got an opening and it goes into space. They're treating space as a physical object, and they're saying, look, there's a hole in space, and that hole in space takes you through a tunnel that could take you to another universe for all they care. So they've drilled a hole through space. That's what they've done here. How did they do that if space is nothing? Okay, they had to turn space into something. And if you look at number 14 now, I'll tell you what that something is. Look at number 14. This is David Blair, and this is what this physicist, so-called physicist, says. This is a PhD, by the way. You can see all his gold medals there. He says space is a very tangible material with tangible properties like stiffness and shape. The most important thing to keep in mind about Einstein's universe is the fantastic stiffness of space, of the rubber sheet, if you like. The stiffness of solid steel is about 10 to the 11. Space has a magnitude of about 10 to the 43rd. Space is a billion times stiffer than steel.
Wow, that's hard to pull.
I know, because these are idiots. They're idiots by now. And people believe in idiots because they have a PhD. They believe only on the basis of authority. Only.
All right.
Say, oh, the guy with a PhD, I got to believe in whatever nonsense he tells me.
But why would you deny outright a physics that allows space expansion? I mean, the light that we receive from distant galaxies, the more distant they are, the more the light is red-shifted or blue-shifted according to the distance. And that's a good evidence to believe that we are in an expanding universe. What would stretch the light?
If you have a rope, in fact, I've got one here. We have a rope, right? Okay. What do we need to do to create what you just said? All we have to do is change the frequency. In other words, the number of links and the length of each link. In other words, how long each link is and how many links you have for a given, in this case, for a given length of rope. That's what the equation of C equals frequency times wavelength does. And if you change the frequency of a rope, of an object that is approaching or getting farther away, you don't have to have any space encroaching on you, believe me, because space is nothing. So space cannot do anything to you. And astronauts prove that every day because they never rub their elbows when they go out into space. All that exists are the objects, not space. but they had to turn space into something stiffer than steel to drill a hole through it.
All right. So you explained the redshift of distant galaxy by rope stretching, essentially.
Not stretching. The ropes don't stretch. All they do is they curve around. They get, like take a rope, and the more you torque it, the smaller it gets, the longer it gets. All you have to do is torque a rope, and you'll see what happens to the links. You get more links, and the links are shorter. And that's
so why is there a distance dependent torquing of the ropes as with galaxies that are further and further away from us?
Well, the first thing we have to understand is that there are blue shifted galaxies, and they sweep that under the rug. Andromeda is coming towards us. It's not red shifted. It's not getting farther away. It's coming towards us. In fact, most of the galaxies in the local group, about 55 galaxies or so, most of them are coming towards us. They're blue shifted. And so the question is, I thought space-time was expanding, pushing everything out. How is it that these galaxies are coming towards us? And that's where they cheat. And at first they rub it, 99% of the people who heard about the redshift don't even know that there are galaxies that are approaching us. That's the first one. But those who know it, they say, oh, yeah, we have an explanation for that. You see, gravity overcomes the expansion of space-time. And hold it, if it does it for these, why doesn't it do it for all of them? Why doesn't gravity, do it for all galaxies?
I have a response for you, Bill. The equilibrium between the dark matter and the dark energy.
Yeah, dark matter is what I left in the bathroom this morning.
All right.
It weighs about as much.
So let's keep moving.
Well, look at number 17. This is what these people are saying. Look at number 17. Here you have mass warping time. This is their explanation. And they tell you, look, you're not supposed to take this literally. Don't make fun of us, but this is their explanation. They're saying mass is bending space-time. And they say, well, you're not supposed to take the analogy literally. If you really want to understand this, you got to take math at the university level. That's baloney. That's absolute baloney, a baloney argument. I need a mechanism to know what affected that star far away. I need a physical mechanism. I can't do it with mass, and I can't do it with space-time. And that's the problem. The problem is these people want to get away saying, look, we can tell you how this universe works, and we won't let you publish anything that violates our qualitative explanation, our physical interpretations. We say that it's mass bending space-time. And you say, hold it, mass is a concept, space-time is a concept. Oh, you're taking it too literally. You got to take math in order to understand it. I don't need to take math. Look, I was showing today a fellow. Look at this. Where is it? Here. Here's a magnet. Okay, magnet. Here's a piece of metal. Okay. Well, we've seen this a million. Here, there it is. Okay. Okay. Now, tell me something. How difficult is this? How here we have two pieces of metal, right? Two pieces of metal. Okay. Now, do you think you need to go to college and learn algebra, linear algebra, calculus, and trigonometry, and who knows what else to know how a piece of metal attracts another piece of metal? Absolutely not. All you need to do is figure out what invisible entity stands between these two magnets. That's it. You have to make an assumption of the physical object that does this magic. You don't need any math whatsoever. And once you figure out what the mechanism is, it's kid stuff. Even kids will laugh at you. I sent you a look at number 3, the donkey pole. You can't make that bigger?
Unfortunately, no. I can air artificially like this.
Okay, just so people can see it better. Anyways, the point there is, look at the first one. In all cases, you have a farmer pulling on a donkey, okay? The first one has no medium. You can't see very well. It's dark. It's too far away, whatever the case. You don't see what's happening. And you say, okay, he's pulling on a donkey, or the donkey's approaching the guy. Which one are you going to propose? Are you going to propose particles? Is he shooting balls or rocks or something at the donkey? Is he throwing waves at the donkey? Or is he pulling on a rope? Which do you think you would simulate this with? How would you explain this to an extraterrestrial, for example? And the issue here is these people want to do pull with particles and do it with waves, with transverse waves. That's the problem. And it doesn't work. It hasn't worked in 400 years since Huygens and Newton got at it. There's no way you're going to do it today.
I don't take issue with a wave potentially pulling. Imagine that you have a wave of certain properties. Let's call it blue and red. I send this wave, blue, red, blue, red. And imagine that I'm a guy who likes to grab blue and pull red. Of course, I can induce, by sending you that wave, I can induce the reaction of, oh man, blue is here, oh, red is here. And depending on my property as a receiver of the wave could very well pull me.
How does a wave pull? You're saying that love pulls you. A girl doesn't attract you physically in the sense that she's pulling on you, like tugging at you. No, it's like showing the donkey a carrot. Yeah, the donkey will come toward you, but does that mean the carrot pulled on the donkey? No.
Here's a better explanation, okay? Imagine I'm a guy with a magnet in my hand like this, and all I do all my life, no matter what you do, Bill, and whether you send me a wave or not, all I do is hop, 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 hop. And when there's no wave coming, I'm just a guy moving my hand with a magnet on my fingers. Now, when you send me a wave, there is a certain time at which a magnetic force will be there, and as I do this, I will pull myself in that direction. And so a wave can very well carry negative potential from that perspective if you give some property to the receiver of the wave. Maybe all atoms in the universe are like grabbers of gravity. They're just looking for these waves of gravity coming in.
Well, let me tell you, the problem is, first, there's no such thing as a wave. That's where the problem starts. You have to say wave of what? Second, you mentioned magnet. Yeah, magnet will do that, but you got to know how a magnet attracts. Otherwise, to say that a magnet did it, you haven't answered the question. You haven't said what is the mechanism by which a magnet produces this effect of attracting from a distance. That's what we want to explain. So yeah, if I wave a magnet like this one, here, if I wave that, around, and every time it comes to this one, you got to get there. If I move this one around, right? What I got to explain is that. That's what I got to explain. With a magnet, I can do it, but I need to explain how a magnet does it. And with a wave, again, you need to know what a wave is. A wave of what? What is this wave? See, you can't use the word wave. Wave is a verb, not a noun.
Agent Orange on the regular chat just gave a name to my invention. It's called Universal Grabbers. I'm a universal grabber.
Grab. Okay. I like that.
All right. Let's continue.
Maybe tell it to the mathematical physicists. They'll take it. The universal grabbers. Well, anyways,
no, but that's one thing that I find extremely weird. And I have to say, I'm following you on the whole dismissing of the space-time concept. I think it's a concept that will be abolished one day. I think it's kind of a metaphor for what's going on, and I don't know what will replace it, but something is telling me that there's not literally a space-time, because the number of operation we had to add to space-time, which is Einstein saying it should be curved, and, well, some people would argue Lorentz actually said it should be curved, and then Einstein comes in, and then the gravity can bend it, and then the cosmologist comes in, and it can be stretched by dark energy. It can be compressed or limited its expansion by dark matter. At this point, I think that we've essentially raped the space-time, and it will eventually convert into another entity.
Well, the question is, what comes first, the extinction of man or or a change in our notions of space-time? But continuing, black hole has several problems as far as I'm concerned. And these are conceptual problems. These are not things that I need to verify in the lab or through a telescope anyway. And I don't need to pragmatically or empirically verify any of this. We need to know what a black hole is. And again, I have a problem with a two-dimensional versus a three-dimensional black hole. I have a problem with the singularity. I have a problem with whether a black hole, in other words, a star, right? Because this is a gravitational collapse. The star is collapsing upon itself because it's massive, right? And it's compressing itself inwards. And the question is, does it stop at a ball, or does it continue until it's a singularity and crushes all matter out of existence? Well, you'll find, PhDs out there saying, oh, it crushes all matter out of existence. But it turns out we have a circular argument, because it turns out that if mass is the quantity of matter, or a measure of a quantity of matter, and the black hole crushes all matter out of existence, we should have no mass. But see, these people get rid of the atoms, they get rid of the elephant, and they keep the mass. And they say now the mass is a ghost, a spirit that's out there that's causing havoc. That's where we have a problem.
Personally, I don't think it gets them out of existence. I think it's a game of word they're playing when they say that. Out of existence, in the sense that as an external observer, you will never be able to see that atom again. But I don't believe that any information is lost in the black hole, since I believe in the quantum information paradox. I don't believe that there is information destroyed by the black hole. In fact, I think it accumulates information at the surface of its event horizon.
Yeah, but see, that what you just said is not true. See, because these people are saying, where do I have it here? I'm trying to find it. Where you have these PhDs saying specifically that it crushes all structure out of existence. It's not just a wording. It's real. They believe that it crushes structure out of existence, and it wipes it out. And that remains. In other words, they say that between the event horizon and the singularity, there is nothing.
I think that the physicists you're talking about have abused language there, and they were at a time where they had not examined the question in depth. Since then, we have solutions that develop that can stack the information at the surface of the event horizon because of the infinity of slowing down of time at this point. And we can send it back into the universe using Hawkins radiation. And so I think we have a more refined view of this today. And today, a modern physicist, a young physicist like the host of PBS Space Time would not say it gets the matter out of existence. He would say it is a format of transformation of the matter.
It's because you don't like what they're saying. And what they're saying is that it crushes matter out of existence. And we cannot, and these guys study, they have a PhD in so-called physics, mathematical physics. So who should we believe? The guy who says it crushes matter out of existence, or you? I mean, do you have a PhD in mathematical physics? I'm going to trust him, not you. I mean, I know you're smart and you're an intelligent guy, but I got to trust him because he's got a PhD. He's got authority. You don't. Where's your medal? Where's your wolf medal?
My only authority stems from my regular chat in my audience who keeps listening to me, and they know that I'm right deep inside.
Well, I know you're right, but I mean, I got to go by what they go because.
All right, so let's just agree on this. That there are some physicists who have abused language about black holes, and the reality is very different. That being said, is there something at the center of galaxy that's pulling stuff?
Pulling. You mean like
pulling with ropes? Let's say, is there the relationship between the sun and the planet Earth? There's a pull there, right? Is there such a pull at the center of our galaxy?
Yeah, I think there is. In fact, I have a totally different explanation for black holes phenomena and for dark matter. If you look at in pictures, I mean, people will look, and again, I'm not here to convince people. I want to make that clear. I'm here to show a mechanism that everybody can visualize, and then they reach their own conclusion. They believe or not, it's their problem. I'm going to show a mechanism that you can see with your own eyes. I'm going to make a movie using objects. I'm going to show a different version of what is known as black hole and dark matter. Okay, that's what I'd like to do next. And if you look at number 24, because we need to walk into this little by little. Number 24, the dark. Okay, this is the problem here. This is a graph that shows that as stars are farther away from the center of a galaxy, they travel faster. You can see the distance is greater and the speed is greater. Okay? And what the mathematicians have done is throw kilograms in there. They say, oh, it's mass. That's the only variable they ever considered. So they say, oh yeah, if we put more mass, we can describe what's happening. Not explain, because they still haven't explained anything. All they did is be able to describe mathematically why the stars on the outer part of a galaxy travel just as fast or faster than the ones on the inside. Okay, so this is the first problem that we have to solve. The second problem is number 25, the one that goes after that. And this is Mr. Ramesh Narayan, and he's from Harvard. And he tells us of a problem. He says the mass of a supermassive black hole is related to the mass of the what is it?
Of the parent galaxy in a very simple way.
The miraculous thing is that all these points lie more or less on a straight line in this plot. He's got a plot there. We're going to see that on the next picture in a minute. It says there seems to be some relation between the mass of the black hole and the galaxy. Roughly, the black hole seems to be approximately 1,000 times less massive than the galaxy in which it lives. Okay? If you look at the next graph, the one that follows that, what is it, 25, I think it is? 26.
Oh, there that's a spectacular one.
Yeah, in other words, what they're saying is the more massive the center of a galaxy, in this case, it would be the black hole, right? That's what they're showing here. The more massive the black hole, the bigger the galaxy. In other words, the size of a galaxy or the mass of a galaxy is related to the size or mass of the black hole. That's what they've shown through observation, and that's what we have to explain. Okay, so we have to explain these two things. First, why do stars on the outside of a galaxy travel faster than those on the inside? And we have to explain what is known as the bulge. Okay, the galaxy bulge. This problem.
Very interesting.
Okay, so let me explain that in a different way than they do. The first thing we have to do is look at the next one, which is number 27. And what I want to show here is that this is the solar magnetic field, okay? And all I want to show here is that the solar magnetic field extends all the way to the bow shock. In other words, it extends all to the heliosphere and outwards. In other words, we're talking about something that's humongously big, the magnetic field of the sun. Now, if you were standing on Pluto looking at the sun, it would look maybe like Venus, like a little dot in the night sky. And yet, the magnetic field of the sun goes way beyond Pluto, all the way to what is known as, again, the bow shock, that whole region. And it interfaces with interstellar matter, in space. And so all I want to show here is the magnetic field is humongous of the sun. You can see the sun there is a little dot, and the magnetic field is just outrageously big. And if you look at the next one, the galactic jets, number 28, same thing. We have, even though it's, I think it's bigger than this, but what they illustrate here is that if that's a galaxy, you're seeing it sideways like a plate. And the magnetic field extends all the way to the edge of the galaxy. I say extends way beyond that. It extends way beyond that, but let's assume this is the case, okay? This is their version. My version is that the magnetic field extends all the way to other galaxies. That's how big the magnetic field of a galaxy is. Not only is it big, it's powerful because it's made out of the magnetic fields of every star in it. There are billions of stars in a galaxy. Each one has a magnetic field, and the magnetic field of the galaxy is, in a way, the summation of all these fields. Okay, so I'm saying that the galaxy has a very powerful magnetic field, And the interesting part is that no mathematical physicist talks about the magnetic field when they talk about either dark matter or black holes. Okay, so now let's look at the next one, which is number 29. This is my proposal. Mathematical physics says that all particles are discrete. There's no connection between them. I say that all atoms are interconnected. That's the foundation, okay? That's my assumption, okay? So it doesn't mean you have to believe it. I'm just saying that's my assumption. That's what I'm going to work off of. And look at number 30, the spider web. We're going to be putting a spider web on top of the galaxy. In other words, we're going to say that all atoms in the universe, as well as all stars, are interconnected like a spider web right there. We're going to put the spider web on top of the galaxy just to illustrate that all atoms are interconnected, all stars are interconnected. So when a galaxy rotates, it rotates like a bicycle wheel. In other words, the spokes, the hub, and the wheel all turn at the same time. And that explains why we don't need any mass or anything like that. All we need is that to have all stars interconnected, and we can produce the same effect that they do with mass. Okay.
So classically, what they do, I guess, is they put some form of mathematical equation for gravity, and they model an entire galaxy. And what happens is that the outside tends to spin much slower than it really does in our observations.
No, it spins faster.
Faster.
Yeah, in other words, it goes around the galaxy at faster speeds than the stars on the inside. And I'm saying that a galaxy rotates like a carousel because all stars are physically interconnected. Only then can we explain why the whole thing rotates as a single piece. Okay, that's the first one. Now, this also explains the bulge issue without putting any black holes in there, because what I'm saying here is the more stars you have in a galaxy, which is what the bulge issue is, they say the bigger the black hole, then the more magnetic field that a galaxy has. And of course, the power inside the center of a galaxy, which is 10 times bigger than another galaxy, is going to be greater. It's going to be a function of the magnetic field is going to be a function of how many stars are in a galaxy. I don't need any mass. All I need is to show that the magnetic field of a galaxy is greater when there are more stars. That's all I need to show.
So when I was young, we did this little magnetic experiment in which there were iron filings that were allowing us to see the magnetic field. Are you saying to us that the bulges of galaxy is essentially a visualization of the magnetic field?
It's gases and other material that is in the center of a galaxy through which the magnetic field passes. In other words, you have sweeping threads. I'm going to explain this in a second, but essentially a magnetic field consists of threads that come from the ropes that interconnect atoms. These threads come out loose, they sweep around the galaxy, gazillions of them going through the center of the galaxy and out from north to south, south to north, whichever way you want to look at it. Okay, and really they go from south to north if we go with a conventional way. And any material, any star in that region, any gas, any particles, they get pushed around, and there's this turbulence inside the center of a galaxy. In other words, this is what's causing that light that these people took a picture of. But let's continue. I just want you to understand the mechanism that I'm proposing. Okay, if you look at the next one, which is the ball, number 31, I think it is. Yeah. This is a charged ball in a sweeping magnetic field. This is here on Earth, by the way. It's a picture, but we see this every day. If you put a charged ball in a magnetic field, it'll spiral. It'll go around nothing. There is no black hole in the middle of that circular motion. All we have is a magnetic field sweeping downwards, and the charged particle sweeps, goes around in circles. We don't need any black hole there, okay? And if you look at the next picture, you see the same thing. You see on the lower right-hand side, the little ball that we just saw, and the magnetic field of the galaxy, which is sweeping threads, is forcing or compelling a star, which is already a charged object. It's got a magnetic field. It's compelling it to move around in circles. We have the same phenomenon. We don't need any black hole. We don't need any mass. None of that nonsense. All we have to do is look at the magnetic field of a galaxy.
So you believe that is that something that most physicists agree on, that the rotation of galaxy is of magnetic origin?
No, they don't.
No?
No, because they do everything with mass. They say, oh, yeah, a galaxy has a magnetic field, and that's all they say, and then they never use the magnetic field again. They do everything with mass.
Okay.
So they don't use the magnetic field. That's the problem. Okay, if you go with the next one, so we go real quick through these, and that's Cygnus. You see here's a rotating magnetic field, and it's pulling smoke. It's pulling a gas because smoke is made out of particles, really, okay? And, molecules, you could say. And this is a rotating magnetic field, and it's drawing the smoke in there, and the smoke disappears into it. I want you to see that, because that's exactly what we'll see in the next one, in the next picture. And again, these are mechanisms.
I might be doubtful on this one. Is that not a wind effect there?
No. This is a rotating magnetic field that the guy turns on, and he also makes it run faster. And when he does this, you'll find that the smoke is drawn in there. It's drawn by the magnetic field.
Okay.
But what I want to show you, look at the next picture, the one that's coming right up, and we have the same situation. They say, look. What we see is gases from the skin of a star, and it gets sucked into nowhere. Well, yeah, if the magnetic field of a galaxy sweeps down a star, it has the potential of ripping the gaseous skin of a star without any mass being involved.
All right.
And if you look at the next picture, the one that follows, which is a different interpretation, we have two galaxies. Their magnetic fields overlap, and the same effect can happen. You can have maybe a star twirling around nothing, or you can have the gases from its skin being ripped off. So there are these things need to be studied if people want to look at an alternative to this mass nonsense. And I say it's nonsense because mass is put in by hand. They put kilograms in there artificially just to make the equations come out right. People are not aware of that. They hear dark matter, black holes, and they say, oh, they found these objects. No, they haven't found anything. It's invisible. It's conveniently invisible and heavy.
All right. I mean, okay. I'm willing to believe that magnetism has been ignored too much, and that future models of galaxies may involve magnetic effects like we don't have right now. Then
let me because now people might ask, well, how do you do this magnetism with Roche? Because that is the core of what I just explained. Let me show you a little sequence here, maybe 6 GIFs that will put the magnetism in the proper perspective for anyone to judge for himself, because all they have to do is look at the picture and say if the mechanism they are observing is what they observe with magnets. And here it is. If you go with the first one, which is number 35, here we see something really incredible that very few people are aware of. People usually sprinkle iron filings around a magnet that's on a desk, on the surface of a desk. Here we see a magnet underwater, and we can see that the so-called magnetic field is something in motion. It pulls one iron filing at a time, and it reflects what James Maxwell said. He said, look, I don't know what it is, but a magnetic field is matter in motion. It's matter in motion, some exotic matter, obviously. But, this magnetic field, whatever it is, it has the ability of pulling one iron filing at a time underwater. And this shows that it's a dynamic entity, this so-called magnetic field. It's not something static that just stands there, holding all these iron filings on top of your desk. No, if you put it underwater, it'll pull one at a time. Okay.
just to give a little opposition here, what we might have is, yes, there's a dynamic phenomenon, no question. The magnetic field could always be the same. However, it could be processed differently as the filings block or interfere with some of it, while other filings may be more free, depending on their surrounding. The environment at a local filing may be influenced by the filings around, right?
Yeah, and again, all I can do is propose a mechanism for how that's happening. Not only the magnetic field of the galaxy, but here, like in this, we just saw a second ago, the magnetic field underwater, what it's doing to each iron filing. And this is what I'm proposing. Again, physical mechanism. If you go with the next one, number 36 there, this is the mechanism I propose for attraction and repulsion. Okay, you imagine two fellas, they're skipping rope. The rope of the first one comes up, the rope of the second one comes down because they're both going counterclockwise, the two at the top. And the rope of the guy on the left latches onto the rope of the guy on the right and pulls on it. That's the mechanism I propose for attraction. On the bottom, we turn this guy around, and obviously now he's spinning his rope clockwise against the other guy who's spinning it counterclockwise. What do we have now? We have the ropes clashing against each other and pushing each other away. We have repulsion. So this is the mechanism.
Interesting.
This is what I'm going to be explaining in a second here. So if you go with the next GIF there. Okay, what am I talking about? I'm saying that a magnet has these rows of aligned molecules, right? I put them here as atoms, but you can see what they're doing. The rows are facing, you're facing along the rows. Those little lines there, the purple and green ones, they're rows. A magnet is divided not into north-south, it's divided into top and bottom regions. The top region has all the rows of what I call serpentines, the rows of molecules. They're spinning in the same direction on the top, opposite to the ones on the bottom. And what you have is the threads go through the center of the magnet and outside, and out the outside of the magnet. And it forms this pattern that is, very familiar to a lot of people, with the iron filing just crowding around the motion of the threads. And again, what I'm saying is a magnetic field is the movement of threads. The famous lines of force that Faraday noticed, they're not abstract. They're real lines. They're physical threads that are moving around a magnet. Okay, that's my proposal. Right. And
very interesting.
Now if you go to the next one, now you can see the mechanism. If you had the two guys on the top, the two going clockwise, counterclockwise, the two on the bottom go clockwise, okay? So you can see that on the left magnet, the guy on the top is sweeping his rope counterclockwise. The guy on the bottom goes counterclockwise. Same with the two guys on the right, okay? The left and right, the same thing. And what happens as the rope of the guy comes up, it latches onto the rope of the guy on the that coming down. And in the case of the magnets, you got the same situation. You have the threads spinning around. The upper left-hand part of the magnet, the upper part of the left magnet is coming up when the upper right one is coming down and latching onto it. The one on the bottom does exactly the opposite. As it comes up on the right, on the left, the other one comes down on the right. And so what you have here is that situation where they're latching onto each other and pulling each other one to the other. What's happening is as they get closer to each other, more threads intervene because the distance is less, and now you're pulling faster and faster and faster. That's why you have the square of the distance phenomenon between two magnets. If you look at the next one, this is the magnetic attraction. Here's you have repulsion. You turn one of the magnets around. Now you have north-south against south-north. And again, here you have the threads spinning around. The two top ones hit each other and the two bottoms hit each other. And they repulse, they push each other away. So this is the mechanism I'm proposing for magnetism. Okay.
Fascinating, very interesting. That we had already reviewed some of those details. So yeah, I'm good with this model. It's a very interesting take on magnetism.
Yeah, it's something that needs to be investigated by people. Let me tell you the problem, JF. The problem is that you can't publish. See, I published my stuff anyways, but I had to publish it in China, where nobody reads it. I guess they don't even read it in English over there. And I published my stuff, but the issue is that, in respectable journals, they will not allow you to give a qualitative interpretation to anything. You have to only bring quantitative analysis. In other words, equations. They don't want to see pictures, pretty pictures, kindergarten pictures in your brief or your manuscript, because that's considered too kindergartenish. So they say, no, we're not interested in that. We're never going to understand this universe. All we need is more money to keep breaking, smashing particles, and we're going to continue with our equations. And so you cannot bring you cannot introduce another perspective to these problems so that they can be investigated further. That's the problem.
Yeah, well, the problem that physicists will take with that kind of model is the rope necessary? Because if I have a mathematical description of fields that do result in acceleration of the two magnets, then the rope is an extra thing. It's like I don't see a rope, so there's no reason for me to invent a rope. And if I have the mathematics that describe the attraction and repulsion, then I've summarized anything that the rope hypothesis would bring to me.
Yeah, and again, if like I showed a minute ago with the donkey, what are we going to use? Are we going to continue using particles and waves when you cannot produce pull with either one? We cannot see, the problem with particles and waves is you cannot produce action at a distance. That's what they've never been able to explain. They can explain push, particle hits particle, they bounce away, no problem there. But how do you produce pull with particles? I can't throw particles at you and pull you. You have to have an elongated type of mechanism, or you're going to have to put a spirit in there in that same space.
All right. So let's continue.
Yeah. So, again, the problems I have with a black hole are several. I have a list of problems with them. One of them I mentioned is the 0-dimensional, 2-dimensional, and 3-dimensional. How many dimensions does a black hole has? Well, it has all of the above, because they covered every base. So if you say, well, is it a hole? Yeah, it's a 2-dimensional hole. Is it a ball? Yeah, it's a 3-dimensional ball. It's everything. It's 0-dimensional singularity. It's everything. And so people don't even ask that question anymore, because the answer is all of the above. Then you have the issue of, what is a black hole made of? And they asked this question to PhDs. The BBC asked Max Tegmark, asked Michio Kaku, some of these big names, these celebrities in mathematical physics, and they asked them, what is a black hole made of? And they all went, I don't know, and the answer is it's made out of mass. That's what a black hole is made out of, right? I mean, some of them have charge, right? Some of them have angular momentum, but all of them have mass. That's the key point of a black hole. So why didn't they answer that? They should have said, yeah, it's made out of mass. Well, if they would have answered that question, then they would have had a problem, because they would have said, what do you mean it's made out of mass? What is mass? I thought mass was a concept, an undefined concept.
All right. So definitely you take issue with black holes. Now, when you look at the photo that they've taken, what's your take on it? Is there a mass absorbing light in there, in the middle of the donut?
Not a mass. What you have is gases. You have particles. You may have even a star nearby, and all of these are being swept or twirled around by the magnetic field. In other words, by the magnetic threads sweeping through the center of a galaxy. So if that's the center of the galaxy, we will concede that. We will say that that's the center, and that black region there is where you have the magnetic field sweeping through there. The bright part, that's gases, etc. They say it's falling inside a black hole. I don't think you need that. All you have to have is a magnetic field, the threads sweeping through that smudge in the center, and you can produce the same result. In fact, I'm sure you can produce the same effect with magnets here on Earth.
Let's see if I understand correctly. this would be the center at which the big bulges of magnetic fields pass. Therefore, it's violently magnetic in there. And for that reason, any particle that finds itself there would be automatically propulsed north or south. And that's why we see an empty space. In the end, it's empty because it's been jetted away by magnetism.
In fact, if you look at, which one was it? The jet. Look at the one that says jet, which is number, because that has a picture of it. Number, which one is it? One that says jet.
There, I have it here.
You found it? Yeah. See, the one on the left, upper left, those are the jets. And if you read, it says that it's caused by the magnetic field. So the jets are supposedly magnetic fields which supposedly interact with a black hole. Well, we can get rid of the black hole. We don't need it. Those jets are the magnetic fields. I mean, a sun has jets. You know, they have all these flares that come out. You've seen some pictures maybe someday. And they don't talk about black hole being in the sun. All you have is these jets coming out. Why? Because they're flares that are carried by the threads, in my case, right? Threads swinging around, and these are the famous jets coming out of either the sun or the galaxy. You don't need mass at all.
Well, Bill, that is a very solid presentation you've done today, because there's no answer from the physicist as to how do you test between the difference between magnetism and gravity? How would you know that that's a black hole or that is just an effect of jet propulsion? And I was noting that they were often saying that the black part of this donut is the size. It's much bigger than a theoretically planned event horizon. It's 3 or 4 times bigger, I believe. And so that would leave place for that kind of magnetic mechanism to perhaps be a better explanation.
Yeah, I think the only way to resolve these issues, and every person has to do it by himself, you know, is try to rationalize it to yourself. I mean, you've got my version. It's a mechanism that I'm proposing. What do they propose? What do I propose? You ask them, what is your mechanism? How does mass do this? Tell me the physical mechanism. And if they just say, look, it's just a description, mathematical description, I have the equation, that's not enough, because I need to know the mechanism, how the farmer pulls on the donkey. You know, we can all understand that, but if the guy just says, you know, the mass of the elephant weighs down, and the you know, space time, and we get rid of the elephant, we got the kilograms, we have space time, but we don't know what the mechanism is, how it affects a star far away, then we got a problem, because we still don't have a mechanism. And the question is mechanisms.
We have a few reactions from the crowd. White Supreme says, ask Bill about static versus dynamic forces.
Horses. Oh, or forces.
Forces.
I don't know what a force is, but whenever someone defines words, these are the words, I'll put them up front so that people don't ask any question concerning the word force, the word time, the word energy, mass, and field are prohibited. They're forbidden. You can't use them in physics because they've never been defined. Second, they're mathematical mumble jumble. Nobody knows what those words mean.
All right. Vince Landry says,
I don't know what they're talking about. There's only 2 forces in the universe, by the way, push and pull, and that's physics. All this other stuff, you know, gluons and, you know, weak force, and that's nonsense.
Fascinating. I love the elementariness of it. Vance Landry says, he sounds like the E. Michael Jones of physics. Zoomer Hub says, the only truth is my dick and the female booty. I am an animal, and an animal with needs, and space is irrelevant. Make babies and do it with prestige. Double Dog sends $10. Thank you so much. He says, when Michelson and Morley was reconsidered decades later, factoring in relativity, its logic alone no longer disproved the ether theory. Have you seen standing wave structure of matter theory?
Yeah, I've seen the matter theory. We have to identify the physical object. The problem with the ether, again, I've been covering it, in fact, in presentations these last few days. The ether is someone has to define first, is the ether made out of particles? Second, is it infinite? Is the ether the same thing as space, or is ether some balls that are contained within space? Are these two different things or one? And so all these questions have to be answered before we can deal with the ether. And just on Michelson-Morley, I just want to make a comment there that, and again, there are different opinions on this, but I read that Michelson and Morley, they themselves did not believe that they disproved the ether. Okay, they themselves, they felt that they confirmed it in some way or another. They just wrote about it. They had their own interpretation on what the ether was. But everybody who looked at it, especially Fitzgerald was one of them, they said, "Oh, this shows that there is no ether. Then what is the waving of light?" And so, they ended up with saying, "Well, light is the undulation of nothing. It doesn't need a medium to vibrate." I say, "Oh, great." That's a great
solution. When they call the ether theory totally debunked and has been demonstrated false, I laugh in their face because quantum field theory is essentially an ether theory. When you start saying, well, there are fields everywhere and that's how they work and they have property A, B, C, I'm sorry, you just invented an ether.
Not only that, I have a statement from Nobel Prize Laughlin, and he says, look, this stuff that we have there, this particles coming in from the void, virtual particles, etc. It's an ether, but we don't use the word because it's taboo.
Exactly. That's one of the great hypocrisy in public education physicists, where they say we've debunked the ether theory. No, you ran back to ether theory for decades until you were back there. Double Dog says, does JF have big enough hair to be a great thinker? Well, if I don't, I can let them grow. And Double Dog says, rotating mask in viscous hair creates an axial indraft of hair that will suck things in. Do you have a control for the smoke experiment?
No, I don't. It's very hard to obtain such things that allow you to show a different aspect of things. There's not too many people doing what a magnetic field does to smoke or to gas. It'd be nice to be able to do something like that so that we could investigate these things. But again, nobody's researching these things. Nobody cares about how the Mother Nature runs her shop. Everybody just is doing equations and getting paid for that, and going to Harvard and to Cambridge just to get a degree, but not to get the degree because it gives them knowledge. They just find people who can put them in good jobs. That's what it's all about. So nobody's really doing science. Everybody's just doing, pulling a guy that said, oh, you believe like me? Come on, I'm going to put you in my church.
All right, Bill. As always, it was a great pleasure talking to you. I think you made a good case for this magnetic theory. I would put it, as far as I'm concerned, at equal footing with the gravity theory of black holes. I've never heard any scientist debunk that properly, and so I'm going to have to say I'm quite impressed by this, and I can't wait to hear physicists comment on this. Was there anything else you wanted to discuss before we conclude?
Hey, JF!
Oh, Mama JF is here. Hello.
Hey, can you ask him your question why the universe is expanding, but there's the distance between the Earth and the Sun is not expanding?
Okay, so she wants me to talk to you about my pet theory of gravity. So I have
That is a good question, by the way. Why isn't if everything is blowing up, if space is growing, it's expanding, everything should be going farther and farther away from each other, we from the sun, the moon from us, etc. But what's happening is they say that, again, either gravity or electromagnetism overcome that force. That's what they're saying. So they just put a fudge factor in there and they solve all the problems. They never lose.
I'm developing an alternative theory of gravity whereby from a given mass in space, there are rays of expansion of space. However, when these rays encounter matter, they are blocked. Essentially, gravity would be a failure of space to expand. And so you have the Earth and the Sun, and between them, there's less space expansion than on the side of them. And I'm trying to check if that could explain an orbit and everything we know from gravity.
Well, yeah, all we can do is try different theories and then find out which one, meets William of Ockham's criteria. Just get the simplest one, the one that fits the facts, etc. But right now, we don't have anything from mathematical physics. They don't have an explanation. They don't have mechanisms. That's the problem. There's nothing to compare against because they haven't proposed anything. They say we don't deal with mechanisms. That's philosophy. That's ontology. That's metaphysics. We deal with math. That's the problem.
All right, Bill, it was a pleasure talking to you. I'll be continuing the show alone because I have a couple of news to cover, but you are welcome again in the future.
Okay, I hope so.
Bye-bye.
We'll see you next time. Bye-bye.
Bill Gaede is always an interesting conversation. There were